Hi, welcome back to this channel. In this video, we are going to discuss chapter 5.2, liquid. First, we need to know the properties of the liquid. Then we are going to explain the process of vaporization and also condensation based on the kinetic molecular theory. Define the vapor pressure at boiling point and also the relationship. Then we have to explain the boiling process, and then at the same time we will know the difference and the similarity between boiling and vaporization. Last part, we are going to do the relationship basically among the intermolecular force, vapor pressure, and also the boiling point. Let's start with the properties of liquid. The shape of the liquid always follows the shape of the container, while the volume of the liquid is fixed. For example, you pour 200 ml of water from a triangle shape of container into a square container. The shape of the liquid will change from triangle to square, but the volume of the liquid will still fix to 200 ml. Next, liquid generally are considered incompressible. In Bahasa, we call kemampatan. Means that water cannot be compressed. Diffusion in Bahasa is called resapan. As we know, the liquid will always diffuse from high concentration to low concentration. Viscosity means that the resistance to flow. In Bahasa, resistance means bintangan. So the higher or the greater viscosity means the liquid is harder to flow. Why the liquid is harder to flow? Basically, it will be affected by the following factor. First, intermolecular force. Second, the temperature. And then next is the size of the molecule. Generally, the stronger the intermolecular force, the greater the viscosity. The lower the temperature, the greater the viscosity. And also lastly, the bigger the size, the greater the viscosity. Let's look at one exercise related with viscosity. Arrange the following substance in order of increasing viscosity. Okay, let's remind you that viscosity in Bahasa is called kelikatan. So among these three, water, milk, pure chocolate, and also cooking oil. Which one has the highest viscosity, or which one is the hardest to flow? Yes, milk chocolate will be the hardest to flow. So I just write down the term chocolate. And then water is the easiest to flow, so has the lowest viscosity. And in the middle will be the cooking oil. Next, what happened to the viscosity of the honey after heating for 2 minutes? So from here we know that the factor that we need to relate is the term from the term heating, means that we are going to relate with the temperature. So when the temperature is increased, the average kinetic of honey will be increased and cause the intermolecular force become weaker. Once the intermolecular become weaker, means that the honey will be easier to flow and the viscosity is decreasing. The next properties of liquid that we are going to discuss is about surface tension. In Bahasa, we call ketekanan permukaan. So this surface tension make the insect does not sink into the water. Let's look at what actually is the surface tension. So refer to this diagram. Molecule within the molecule, within a liquid are pulled all the direction. So for example, this is the liquid molecule. pull in all directions, while the molecules at the surface or on the surface only will pull downwards and also sideways. This will cause the surface is like tightened as an elastic film. So that's why we can say that this surface tension is going to affected by intermolecular force and also temperature. The stronger the intermolecular force, the greater the surface tension. So if we need the surface tension become greater, so the lower the temperature supposed to be. Now looks at one previous question, UPS 2007 and 8. What is the relationship between intermolecular force and surface tension? So if you still remember, in the previous slide we already mentioned, the stronger the intermolecular force, the greater the surface tension. So you can make it become simple sentence. Intermolecular force is directly proportional to the surface tension. Second part, predict with precision which liquid has a greater surface tension. Since they are under the same question, so it means that they already give us the hint. We are going to discuss about the intermolecular force. So let's look at the intermolecular force for ethanol, which we learned in chapter 4 is hydrogen bond, because the hydrogen is bonded directly to FON. While for the dimethyl ether cannot form hydrogen bond because the hydrogen is bonded to the carbon. So the intermolecular force for dimethyl ether will be van der Waals force. So because of this, we know that hydrogen bond is stronger than van der Waals force. So that's why ethanol has greater surface tension. Now let's proceed for tutorial question number 1. State the measurable physical properties of a liquid based on the following terms. The ability to flow, we will relate with the viscosity. The temperature at where the vapor pressure is equal to the atmosphere pressure. Basically, this is mean atmosphere pressure. So this refers to the temperature of boiling point. Next, the property for the responsibility for the formation of molecules. So this is related to the surface tension. Because on the surface, only the particles or the gaseous molecule only will be pulled downwards and sideways by others molecule and cause them form a molecules. Now, we are going to discuss the vaporization process through the kinetic molecular theory and then also relate them with the intermolecular force. So basically, the changes of the physical state is from liquid to gas and then only involve the liquid on the surface. So this is the part that we might see when the liquid try to escape become the gas, but when it is unsuccessful, it will form back the water droplets. So it's unsuccessful means that the gases convert back to liquid through the condensation process. After vaporization, we also will discuss about the condensation process based on the kinetic molecular theory. So the factors that can affect the vaporization rate will be surface tension, surface area, temperature, and also the intermolecular force. So let's start with the explanation of the process. Liquid actually always will move continuously, okay? Then some of the particles, actually they possess high kinetic energy and they are able to reach the surface. So means that they will try to escape themselves as vapor or as gas. Because they are able to overcome the intermolecular force. Now let's explain the condensation process based on the kinetic molecular theory. So condensation process is where gases turn to liquid. So vapor generally they will move randomly at the high kinetic energy. When the vapor is cooled down, the molecule will going to move slower and then they will lose some of their kinetic energy. And then they are come closer to each other, which cause the intermolecular force become stronger, and then they are in the liquid form. So based on the definition above, we have the idea that the boiling point of a liquid will be affected by the external pressure and also the intermolecular force. Now let's continue with another common terms that will be used to describe liquid vapor pressure. So what is meant by the vapor pressure? The vapor pressure is referred to pressure that exerted by the vapor over a liquid in a closed container. So in a closed container, the liquid will try to escape as gas. So when they try to escape as gas, they will always hit the wall of the container. Once they hit the wall of the container, pressure is exerted. So then, what are the factors will affect the vapor pressure? So first is the temperature, intermolecular force. So now, we are going to continue with what are the relationship between the intermolecular force, vapor pressure, and also boiling point. As when we went through just now, both intermolecular force will affect the vapor pressure and also the boiling point. So now we try to relate all these three together. Both vapor pressure and boiling point are affected by intermolecular force. The stronger the intermolecular force means that the harder the liquid escape as vapor. So if it is harder escape as vapor, we know this liquid is less volatile. So volatile in bahasa can be considered as kemeruapan. If the liquid is less volatile, means that the vapor pressure is lower. So if the vapor pressure is lower, so the higher the boiling point, because the pressure is equal to the external pressure. Now let's look at one question. Explain why the vapor pressure of acetone is higher than ethanol at room temperature. So again, vapor pressure for acetone is higher than ethanol. So we have to relate with the intermolecular force. So when we look at the formula for acetone, the hydrogen is not attached to the oxygen. So generally, the intermolecular force at the acetone will be van der Waals force. While for the ethanol, the hydrogen is bonded directly to FON, so the intermolecular force for ethanol is hydrogen bond. Now, Higher vapor pressure means that the gas or the liquid has lower boiling point. So if they have lower boiling point means that the intermolecular force is weaker. So if just now we already mentioned, acetone has van der Waals force, which is weaker than hydrogen bond. So we are near to the answer. So now we're going to rearrange the idea in proper sentences. Acetone consists of van der Waals force, while ethanol consists of hydrogen bond. So hydrogen bond is stronger than van der Waals force. So therefore, acetone has higher vapor pressure. Let's proceed with tutorial question number 2a. What you understand about the term of boiling point. So as previous slide we have mentioned before, the boiling point is at the temperature at where the vapor pressure of the liquid is equal to the external atmosphere pressure. Second part, the boiling point of a liquid will increase if the intermolecular force is stronger. So why? Because the liquid is harder to escape as vapor. So they are going to need more energy to free themselves. So when they need more energy to free themselves, the boiling point will be higher. And at the same time, this liquid will consider as lower vapor pressure. Tutorial question number 3. Distinguish between the evaporation and also boiling process. So evaporation basically involves the molecule of the surface, and then they will try to escape themselves to turn into the gas. So normally the temperature for the surface liquid to convert to gas is below their boiling point. However, boiling process is involved the entire liquid molecule. They try to escape, become the gas only when the vapor pressure of the liquid is equal to the atmosphere pressure, or we also can know that as external pressure. Next, we are going to use kinetic molecular theory to explain the dependence of rate of vaporization on temperature. Means that you are going to let us know what will happen to the rate of vaporization if the temperature increase or decrease. So if in the kinetic molecular theory, we need to try to relate with the intermolecular force and also the movement of the particles. So as temperature increase, the kinetic energy of the liquid molecule also will increase. Okay, so we relate with the movement. So and then at this condition, the molecule will have more energy to overcome the attractive force between the liquid molecule, and then they're able to escape as vapor. With this, we know that the rate of vaporization will be increased if the temperature increases. Let's discuss one more question before we end this video. The boiling point is related with the vapor pressure. So the vapor pressure given for the liquid P is 0.3, Q is 0.6, and R is 0.8. Now, which liquid going to has the highest boiling point? As we know, if the liquid has the highest boiling point, means that they have the lowest vapor pressure. So based on the value given in the question, 0.3 atm is the lowest vapor pressure, which is the liquid P. Next question. At the external pressure of 0.7 atm, which liquid will remain as its original state? Means that it will still maintain as the liquid. So the answer will be R, because the vapor pressure for R is 0.8 atm. which is greater than 0.7. So means that the R is unable to escape themselves as the vapor. Okay, so with this, we're going to end this video and finish for chapter 5.2, liquid. Thank you for your time.